All right, welcome to worksheet number 18. Here we're going to talk about antiderivatives. This corresponds to section number 3.9. This is the last section of chapter 3. So here what we're going to study is, in this section we'll discuss the opposite of the derivative. So if you're given a derivative, right, is it possible for me to find the corresponding function, right? Because up until now, we have a function, we took the derivative, right? So we're going to kind of go backward. Like if I look at the derivative, is it possible for me to guess like what the function was? So in chapter 4, actually starting next section, we'll talk more about that and then go from there. Definition: a function is, big function f is called the antiderivative. So I'll highlight anti part. Maybe I use green. Antiderivative. If the derivative of the big function f is equal to small f, right? For every x in the interval I, right? So it's called antiderivative. So if you take the derivative of antiderivative, you get that function, right? So let's look at example 1. For which function is f prime 2x? Well, I know, so this is different than taking the derivative of 2x, right? What function do I have to take the derivative to get 2x? Well, it's x to the 1 power, so it must be an x to the square. So that's my guess. We can kind of check. It's like, well, if I take x squared and then prime, take the prime of that, is 2x to the 1 power, so that's that, right? So yeah, this is it. If I take the derivative of this, I get that. So that's my f. So this is like my big F. Is there only one? Is there other options? I'm going to say no, because if I have something like this, x squared plus 5, or x squared minus 7. Because if I take the derivative of x squared plus 5, I still get 2x, right? I mean 2x. If I take the derivative of x squared minus 7, I still get 2x. Because with the constant, when you take derivative, it goes to 0. So these are all possible answers, right? So I want to kind of make sure that when you take the antiderivative, that's going to be always the case when you have this add extra constant. Because when you take the derivative, constant just goes away. So you still get the same derivative. All right. Let's look at example 2. How about this function? Okay, it kind of looks complicated. But I know that there's like a radical, and then if you take the derivative of whatever is inside, that's like x squared, so it becomes 2x. So here I'm going to try to guess. I want to guess is radical 4 plus x squared. Let's check to see if that's actually correct or not. So radical 4 plus x squared derivative. So again, this is like 1/2 power, right? So this is the same as 4 plus x squared 1/2 power derivative. So 1/2 power, decrease the power by 1, so that's negative 1/2 power. So that means 1 over 4 plus x squared times, I'm using the chain rule, so I'll take the derivative of whatever's inside. So that's 2x. 2 cancels out, so yeah, x on the top, radical 4 plus x squared on the bottom. So that means this was a correct answer. So if I take the derivative of this, radical 4 plus x squared, I'll get that as my derivative. Again, is it the only option? No. I can always come up with, basically once I know one derivative, antiderivative, basically I can do 4 plus x squared plus 7. I can do radical 4 plus x squared minus 3. I can do radical 4 plus x squared plus 102, whatever. So again, I can add or subtract any constant, will get you the same derivative. So for that question, I can do 4 plus x squared plus c, where c is any constant. So it could be 7, it could be minus 3, it could be 102, doesn't matter. I can come up with any number and then add them. It'll be still a derivative, antiderivative of this function right here. All right, so let's look at the next theorem here. If f and g are both antiderivative of f, then basically this same function plus some constant c, right? So for example, like here, this is antiderivative, this is antiderivative, this is antiderivative, this is antiderivative of this function. So if you look at them, they're all basically the same with the number different, the constant. That's the only thing that's different. So I can say this is the most general antiderivative of that, right? And then like if I'm looking at just one particular one, this is like a particular one, and if you just keep it as a C, that's a general one, right? Now let's look at example 3. It says find the most general antiderivative for each of the following functions. Okay, so first one is x fifth. So my guess is, okay, the big F is going to be like x to the 5th power, because if I take the derivative of 5th power, it becomes 4th power, right? Let me just check. I feel like I need to do something. So else, take the derivative, that's 5x to the 4th. Well, that's not exactly the same as x to the 4th. So I want to find something so that my answer is just x to the 4th as a derivative. I need to get rid of this 5. So that means I need 1/5. So if I had 1/5 in front of it, then 1/5, then they'll cancel out, right? So maybe I should have had 1/5 in the beginning. Let's check it again. With the 1/5 in front. 1/5 x5 derivative. So that's 1/5 times 5 times x to the 4th power. They cancel out, so that's x to the 4th. So that works. So my derivative is actually x5 over 5. And then I almost forgot, plus c, because they said to find the most general antiderivative. So it could be plus 10, plus 10, plus 12, plus minus 10, whatever. So this is most general antiderivative of this. Let's look at the second one. Derivative is cosine. What do I need to take the derivative to get cosine? It's going to be just sine. So f, big F is going to be sine. Let's check. Sine x plus c. Derivative is cosine x. Well, derivative of sine is cosine. Derivative of constant is 0, so that's it. So that's good. I'm going to have you try this one. So I hope you guys notice kind of from part A, some sort of pattern. There's a number, I increase the number, right? And then I divide by that. So you can kind of try part C. So I'm going to have you pause and work on part C. Be careful with the negative. All right, if you're done with part C, the answer should be big F. Should be x to the -3 power over -3. And again, you can always take the derivative and then you can check your answer from there. All right, let's look at some of the useful antiderivative. So basically, like all the derivative rules kind of apply also. So let's say you have a c constant. So c, k are constants. C of f of x, the most c times f of x, the most general derivative will be c big F of x plus some number, other number k, right? So, and then if you have f of x plus g of x, kind of works the same way. F of x plus big G of x plus k constant. X to the n power, this is probably the most useful. You increase the power by 1 and then you divide by that. And for the trig function, cosine x, well, sine x plus k, right? And then sine x. How do I get the sine x as a derivative? Negative cosine x. And then secant squared. The derivative of tangent is secant squared, so I can say tangent x plus k, and then secant tangent. The derivative of secant is secant tangent, right? So like this. These are useful ones. Only problem we have here, this is probably the most useful one. I have n plus 1 on the bottom, so what if n is -1? Then we don't know what to do. Don't know what to do. So it doesn't apply what to do. So for example, if you have a x to the -1 power, I don't know what's the antiderivative of that. We don't know what it is, right? So what do I have to take a derivative so that I get x to the -1 power, right? it's constant because x is the 0 power, but then when you take the x to 0 power constant, the derivative is equal to just 0. So this will deal with that in math 5b. Okay, it says, let's look at example 4. You notice that here we have something for addition rule, like when you add. Actually, you can actually put subtraction here too. If you're adding or subtracting two functions, I can basically calculate the antiderivative of each one separately. You notice here, none of them has multiplication rule and the quotient rule. So it doesn't work like that because they're kind of complicated, right? So here, that's why when I look at example 4, find the general antiderivative, it seems like it's a quotient rule, which I don't have, so I don't know what to do. But what I can do is I can split these fractions into just addition. So I can rewrite f of x cubed over x plus x squared over x plus x over x plus 2 sine x. So that's x squared plus x plus 1 plus 2 sine x. All right, so once I have it like that, I know what to do with all these things are added. I basically have to calculate each one separately, and I don't add them all up. So big F, the antiderivative is x squared, so I'll raise the power by 1. So 2 plus 3 is 3. I mean, 2 plus 1 is 3, and then divide by 3. So x cubed over 3. X squared over 2 plus, oh, I don't have any x values, so this is kind of like x to the 0 power. So increase the power by 1, so x over 1, x to the 1 power by 1, right? Plus, what's the antiderivative sign? It's negative cosine, so that'll be negative. Here it'll be negative, 2 cosine x plus c. Again, these kind of questions I want to double check my answer. F prime is x cubed over 3 plus x squared over 2 plus x minus 2 cosine x plus c prime. I want to make sure that when I take the derivative of this whole thing, I'm supposed to get that. That's the original question, right? So I want to see that actually happens. So that's 1/3 3 times x squared plus 1/2 2 times x1 plus 1 minus 2 negative sine x plus 0, right? Because derivative of constant is equals to 0. 3, they cancel out. So I get x squared plus 2 cancel out. So that's just x plus 1 minus, so that's plus 2 sine x. All right, that's what I wanted to get. That's what I started with. So this is the correct answer. So all your antiderivative question, you can basically double check your answer. Just kind of work it out, and if it doesn't work, you kind of adjust it, right? All right. Let's get example 5. Let's say if the second derivative of this and f of 1 is 0 and f prime of 1 is 1, here I want to find f, right? Okay, so here notice the question is given f double prime, right? So I'm going to be careful with that. So let's see, f is here, f prime is here, f double prime is given, plus x to the 1/2 power. So I'm going to rewrite it like this. So I guess I have to do it in steps. I'll find the f prime first. So if you look at the antiderivative of this, that's f prime. Get the answer and then take another antiderivative, that'll be your f. So I'm going to have to kind of go in steps. So again, here is 2x to the 1 power basically. Raise the by 1, divide by 2, so that's just x squared. Plus raise the power by 1, so 1/2 plus 1, that's 1/2. So 1/2 plus 1 is 1/2 plus 2 over 2, which is 3 over 2. So x to the 3 over 2 power, divide by 3 over 2, right? And then plus a constant, c. Okay, I don't like the way it looks here, so I'm going to rewrite it. So x squared plus 2 over 3, x to the 3 over 2 power plus c. Why did I have to flip it? Because 3 over 2 is 1 over 3 over 2, so that means it's 2 over 3. All right, so that's that. However, they give you also this information. F prime of 1 is 1. So here we can determine the value of constant c. So I need more space here. F prime of 1 is, I'm going to plug in 1. 1 squared plus 2/3 1 to the 3 over 2 power plus c. I want that to be 1 because they say when you plug in 1, you get 1 as an answer, right? So what does that mean? 1 plus 2 over 3 plus c is equal to 1. Cancel that, cancel that. C is negative 2 over 3. So here I can actually determine the value of c. So here I'm going to erase c. I'm going to say that's going to be negative 2 over 3. So here I can actually determine the value of c. So that's f prime. So I can kind of go through the same process because I want to find f. So I'll just take the antiderivative of this again. So I'll do the same process. X squared raised the power by 1. So 2 plus 1 is 3 power. Divide by 3. So this will be x cubed over 3 plus 2/3. I'll raise this power by 1. So 3 over 2 plus 2 over 2, which is 1, is 5 over 2. So again, 5 over 2, so it'll be 2 over 5, x to the 5 over 2 power, minus 2 over 3x plus c. Again, why is it negative 2 over 3x? There's a constant, so when you take the antiderivative of constant, it'll be just constant times x plus c. Again, I can kind of here, they give you another information, f of 1 is equal to 0. That means I can find the value of this c. So let me write this at the bottom. F of 1, plug in 1 into f. So 1 cubed over 3, so that's just 1/3, plus plug in 1 here, so that'll be 1. 2 over 3 times, that's 4 over 15, minus 2 over 3 plus c is equal to 0. So fraction, the common denominator is going to be 15. I multiply 5 top and bottom, 5 top and bottom. So that will be, I need more space here. 5 over 15 plus 4 over 15 plus 10, minus 10 over 15 plus c is equal to 0. So that's, what is it, negative 15 over 1. 1 over 15 plus c is equal to 0. So c is 1 over 15. All right. Yikes. Okay, so that means I can actually go back and erase this part. I'm going to say, oh, that's 1 over 15. So that's my final answer. So when they give you this extra conditions, we can go ahead and actually find the value of c, so you can get like an exact answer. All right. Let's see. I'm going to have you guys do example 6. It says, suppose a function has a slope this at each point of its graph. That's just another way of saying this is the derivative, because derivative gives you the slope. So f of x, they're saying f prime of x is x squared plus sine x. Then also give you f of 0 is equal to 3. So here I'm going to have you finish example 6. All right, if you're done example 6, the answer should be big F of x is equal to 1/3 x cubed minus cosine x. And then constant, I can actually find the value of the constant. That's that. Next question is basically, again, like in terms of application. In economics, marginal revenue is the derivative of revenue, right? So if they say marginal profit, marginal revenue, that just means it's the derivative. It's just a different way of saying it. It has a little bit of meaning, a different meaning to it, but it just, for us, it's going to be derivative. So it says, find the revenue function if the marginal revenue is this. So basically they're saying find f of x when f prime of x is negative 3x squared plus 2x plus 12, and then f of 0 is equal to 0. And for example 8, it says a particle is traveling along x-axis in a way that acceleration is this thing. Find the velocity, find this position and the velocity, right? So kind of same thing, like in terms of motion, velocity and the acceleration. So this, you can interpret this as f is basically the position, s of t. This is the velocity, v of t. Then acceleration, as a of t. So you have a position function, you have velocity function, and then you have the acceleration function. Basically, that's f. If you take the derivative of the position function, it's the velocity. If you take the derivative of the velocity, it's acceleration. Here, they gave you the acceleration, so you're starting from here. Again, take the antiderivative to get the velocity, and then take the antiderivative of that to find the position function. I'm going to have you finish example 7 and example 8. And that's it for the worksheet. So for the answer for example 7 should be f of x or r of x is negative x cubed plus x squared plus 12x. And for the next one, the answer should be the velocity should be 4t3 over 2 minus 1/3 t cubed. And the acceleration, oops, we already know the acceleration. The position function should be 8 over 5 t 5 over 2 minus 1/12 t to the 4th plus 2. All right, and this is it.